Just close that.
Thanks to the organizer to give me this chance to present our recent work. Basically, in the previous presentation, a lot of people talking about the PubMed. Actually, PubMed is a very important database in biomedical domain, and there are more than 29 million citations in the PubMed. It's similar to other scientific articles. They have a title and abstract, but one distinct advantage of MeSH is that they have index term, MeSH terms. For actually, in the curator in National Library of Medicine, a lot of curators to do the manual indexing, and the cost is very high. Actually, there are more than 100 curators until 2016. So one question is how to do it automatically, or how to using automatic MeSH index to help people to index the MeSH. So, but actually, MeSH index is a very difficult problem, it's very challenging because of a lot of reasons. For example, there are more than 29,000 MeSH terms. And each article has a lot of different number of MeSH terms. On average, it's around 12, and the frequency of each MeSH term varies a lot. We can also compare with the IMGNet and the Medline. So in IMGNet, there are around 1.2 million images, but there are only around 1,000 glasses. So this is also a multi-glass problem. So each image is annotated with one label, but in our case, in the MeSH index, there are more than 29,000 labels, and each article is assigned more than 12 labels, around 12 labels. Actually, there is a challenge in called BioFQ. So the organizer is collaborated with the NIM. They provided the unclassified PubMed articles, and the participants try to assign the MeSH terms to the article. The evaluation is based on the adaptation of PubMed curators. Also, Google is a sponsor for these competitions. Actually, there are a lot of related methods in the BioFQ competition, and in the very beginning, MPI is the official tool in the NIM, and later a lot of method appears during the competition. For example, Dr. Lu in NCBI, they proposed using learning to rank to address this problem, and we also developed a lot of methods. Most recently, deep learning has also used in this domain. Anyway, our work is based on the learning to rank. The learning to rank method is widely used in the search engine industry. So, for example, given the training data, for example, the query and the documents, we try to learn a ranking model to rank the documents with respect to a specific query. When the testing data is coming, given a query and a lot of documents, then we try to using the learning ranking model to rank the documents. In our case, we can deem the citation as the query and the MeSH terms as the documents. Then we try to ranking the MeSH terms. Then we can try to predict the MeSH label for each document. This is previously we're using the learning to rank model to predicting the MeSH label. Given a test documents, we try to, at the first stage, we try to use different methods to get some candidate MeSH terms, and then we try to get some features, and then try to learn the ranking model, and then try to rank the MeSH terms. There are a lot of different advantages of in this method. We try to integrate diverse evidence. We try to normalize the score from each component method. And also we consider the label dependence in the model. And in 2016, we try to, at that time, so the natural language processing, there are a lot of progress in natural language processing in the language embedding. So we think about try to incorporate the language embedding, try to using the word factor, document factor to get the better representation for each citation. Then for each citation, we can combine both the sparse representation and the deep representation to get a new representation, and then try to improve the performance. So in this case, deep MeSH is a kind of combination of MeSH label and semantic representation. Anyway, all preface methods, they only use title and abstract for the MeSH index. So in the last few years, more and more full tests become available in the PubMed Central. So in this case, we are thinking about how to utilize the full text to improve the performance of MeSH index. The basic ideas of FullMeSH is we using the same framework of MeSH label or deep MeSH, but we consider the full text. Given a full text article, we try to segment the full text into different sections, such as the title, abstract, introduction, method, and the result, discussion, or conclusion. And for the, we use different type of representation for the text. For example, the TF-IDF, document to factor, D2F, TF-IDF, and also word to factor for training the different kinds of methods, including the deep learning method. In the first stage, we still try to get some candidate MeSH terms. And in the third step, we get the features from the different component method and try to rank the MeSH terms. And finally, we try to learn the number of MeSH terms of each article and then get the final result. We also use a deep learning model as a component method in the learning to rank framework. Specifically, we use attention CNN, try to using CNN for extract the deep information in the text. Now we can see the result. Actually, we're using whole exist full article until October 2018 in the PMC, and there is around more than 1.4 million overlap with the mainline. We're using around 10,000 articles as the testing data. Here is the result. We can see basically full text is very helpful in all steps of MeSH index, including the generate candidate MeSH terms, ranking the MeSH terms, and learning the number of MeSH terms. Also, we include a lot of different types of methods, including the pattern matching, the KNN, SVM, also the deep model. So all these kind of models is useful to try to improve the macro of measure. We also checked if we remove some sections, then how the result changes. We found that the method is the most important part. If we remove the method section, the performance will drop most. And we also analyzed the result with different type of different MeSH terms with different frequency. Basically, the FullMeSH achieved the best performance in all group of MeSH terms. Specifically, we found the FullMeSH achieved very good result in a special type of MeSH term. Is check tag. It's very frequent MeSH terms, and this result is consistent with the previous work. We also show a case study actually some more information, some more MeSH terms only appear in the full text in the method section, but it not appear in other sections. So for example, here the red part, they only appear in the method section of the full text. So FullMeSH or MeSH label cannot predict these kind of MeSH terms. Anyway, the most important thing we found from this study is we can try to leverage some important information in the full text to improve the performance. This kind of information doesn't happen in the title and abstract. And finally, I would like to thank my students and collaborators in this study. And thank you very much.
A minute for a quick question. So I ask a quick question. So, the work shows that this deep learning method continue to improve the accuracy of automatic MeSH indexing. Indexing. And so, where do you see next? Because we don't know the actual official number, but I can expect even you compare two indexers, they have a disagreement quite a bit as well. So, where do you think this will go next?
Yeah, this is a very good question. We are also thinking about what's the upper limit of this task. Because when we start attending this kind of competition, maybe the best method is maybe around 0.63. Now is around 0.7. So anyway, as you said, there's also some kind of disagreement between the curators. Anyway, we are thinking about.
Okay, thank you very much again. So we'll move on to the next talk by Xiangyin Jiang from University of Delaware, and she'll talk about effective biomedical document classification scheme in support of biocuration, addressing class imbalance.